Guys, welcome back to my YouTube channel, DotNet-Dev-Journey with Jacob. And today is my day 5 of my journey to becoming a professional .NET developer. In the last class, which is day 4 of my journey, we learned the basic principles of object-oriented programming together. And today we are going to be discussing one more principle called the interface. Interface is very much like the abstract class with abstract methods. So it is like a rule book, a promise, a contract that the implementation class gets to implement. So in the interface, we only define the method, but we do not uh we don't define the method statement or the block of code to be executed by that method. We only define the method. For instance, let's look at this. Okay, let's come here. An interface. We'll only define an interface by, let me quickly add, excuse me. So, I mean, this as test, for example. So an interface, as you can see, it already recognizes it as interface, and I'll tell you the reason why. So for an interface, you can just say void add tests. So I can say tests and say tests, or let's say student, student, and that's all. So in an interface, we just define the method, but we don't define the execution or the block of code that will be executed by the method. So the implementation class will be the class to implement this. So and let's quickly have another uh, another class to this so that we'll see. So this will be the implementation class, and here the implementation class must inherit from the interface. And here we can say public void add test students. Then this here will implement and define the rules or the block of code that will be executed by the method. So, and to name an interface, it has to start by I, the initial I. So, as you can see, if you notice when I was creating the interface and I named it iTest, immediately I launched that and it opened, it already, you know, recognized that I'm trying to create an interface class, an interface. And here, instead of just simply saying class, it just uses interface. So the naming convention is using an initial I to specify the name, to give the name of your interface. So if I want to say student and I want it to be an interface, all I need to do is I student. So .NET framework understands that I'm trying to create an interface. So um, I think I know one question would be if interface is similar to an abstract class with an abstract method, then why the need for interface? So here's where the big and major difference lies. A class can only inherit from a single parent class. So class A can only, or class B can only inherit from class B, but class C cannot inherit from class A and class B. So if class C wants to inherit from class A and class B, the only thing, let me do this. Class C, for class C to inherit, so class C cannot do something like this. A, comma B. We are going to run into an error. So the only thing that can make class C inherit both from class A and class B is if class A inherits from class B first, like this. Then class C class C can then inherit from class A. Because, or let's say, if class B should be class B inheriting from class A, so class A is the parent class. Class B is a child class inheriting from class A, then we can now say class C inherits from class B. So if class C is inheriting from class B, which means it's also inheriting everything that class B has inherited from class A. But sometimes that might not be the case. We might not want to inherit from class A directly because we need to achieve something called solid principle design. If we want to work on designing a very good um, project that does not only solve the problem of now, but has the ability to solve the problem of the future. So we might want to, segregate our concerns from each other, like segregation of concerns, and we might not want to do this because it means that class C might not need everything that is in class A. So why inheriting it if it does not need everything in class A? So that is what interface helps to solve. So here, if we have more than one interface, a class can inherit from more than one interface. Can inherit from class IA and comma IB, comma IC. So as many interfaces as possible. A class can inherit from more than one interface, but a class cannot inherit from more than one parent class. I hope you get that. So that being said, another thing we'll be looking at is solid principle design. Solid principle design. Solid principle design or solid design principle rather. My bad. I beg your pardon. Solid design principle is a principle that helps us to uh, design or develop a project that is beyond now and has the ability to, you know, to scale even as the application becomes bigger and bigger. So solid principle helps an application to possess the ability of taking in new features or scaling without crashing, without breaking down, without having to rewrite the program from the start, or without having to stop the program. So while the program is, running, we can add new features to it without crashing the program. That is what it is. And it helps to also solve the problem of tight coupling. So it helps us to achieve loose coupling. So I'm going to be defining what each of the alphabets of the solid design principle mean. Alphabet, I mean SOLID. And we are going to apply that principle to this student management um, project right here so that we can see how it works. And I believe that will help us to understand it better. And please don't forget, we are learning together. We are learning together. I'm also learning together with you guys. So, yeah, we start with the S. S means single responsibility principle. So it means that every class should only have a single responsibility. It means that um, a class would only have one reason to change. For instance, if we are to look at, let's say, an bank account management application. For a bank account class, we know we need account name, account number, what else? Balance, and what are the behaviors or the functions, the methods that can be performed on the accounts is the withdrawal and deposits. So that is what the bank account class and account class should entail or should contain. So we know that that's a single responsibility because all it does is it takes withdrawal and it updates the balance. It takes deposits and it updates the balance. So it has just one responsibility, which is to modify the balance based on either your withdrawal or your deposits. But if we are now adding, let's say, to that same account class, we are adding save to database function. We are having print account statement function. Then it is now more than a single responsibility because there might be a need in the future to change or modify how the account details or account information is being stored in the database. And if that changes, that means that we will need to modify the entire class. The class will be affected. Or if peradventure we decide that, okay, instead of printing to paper, we want to print to PDF, it is also going to change. It is going to, cause us to modify the code in the account class, which is something we want to avoid. So the save to DB or print account statement should not be in the same class as the account class. So every class should be able to perform a single responsibility. That means contains a data and the operation that directly affects the data in that class. And for an account, what are the data, account number, account name, the balance, maybe the creation date, and what are the functions or methods that directly affect the data in an account class? It is the deposit and the withdrawal, which impact on the balance property of the class. I hope that is understood. So quickly we'll go to the O, which is open close principle. It means a class should be open for extension but closed to modification. So simply put, you should be able to extend a class by applying, let's say, a new behavior other than modifying the class. You should do your class should be closed to modification but open to extension. For instance, we have, let's say, a car, car class, and we know one of the behavior of a car is to drive, to brake, and maybe there's a new feature or function that is coming up in the 2026 model of that same car. Instead of modifying the old car, the car should be able to allow for just adding that new behavior into the class, the car class, instead of modifying the entire car code. So you should be able to just, chip in the new behavior that's of the feature you are trying to add to the car. So I know we might not get it completely now, but as we apply this principle to the student management class, I know we'll, grasp it better and more fully. So we've touched on the S, the O. So now we are going to be touching on the L. The L means least curve substitution principle. So it means that a class, a subclass, or a subtype should be able should be should be substitutionable for a base type. A subtype should be substitutionable for a base type. I give an example. If you go to a mart or a store to purchase any item and you want to pay, there are various forms of payments. You can see the card payments, you can see cash payments, you can even have the contactless payments. All these are payment methods. So for the payment method, you should be able to the program should not be restricted to, let's say, cash payments. So if the program is restricted to cash payments, what if you want to do card payment? That means you won't be able to do that. So you should be able to substitute a subtype for a base type, which means the a card payment should be substitutionable for cash payments, and cash transfer should be substitutionable for card payment. So you can substitute any of these subtypes for the base types. So we move quickly to high. High means um interface segregation principle. So segregation of interface or separation, that um if that sticks well with you. So mean that we we ensure that our class, like, we are just, let's say, separation of concerns, so that our class does not depend on functions that does not concern that class. So simply put, to say a class should not depend on functions that does not concern it. So we should be able to separate concerns. Okay, let me explain it better this way. For this student manager, you can see we have add students, remove students, search students, and we also have calculate average, IS score. These are two different concerns that we are putting together in the same class called the student manager. The calculate average, IS score, lowest class, can pass. This should all be in a separate class because it does not directly affect the file management of, let's say, adding a student, removing a student, or the file manipulation on this student class. So it shouldn't be directly or dependent, because now it's dependent on it, but we should be able to segregate the concerns here. So that is what interface segregation principle means. And the last one is the D, which is the dependency inversion principle. So dependency inversion principle means that um a high level module should not depend on a low level module. That means that classes should not directly depend on another, as this is the bedrock of achieving loose coupling. We should the dependency inversion principle helps to um limit or eradicate tight coupling. It helps to ensure that there is no direct dependency on another class, so that when there is need for scaling, it will be easy to scale, so that it will not our system will not be rigid. So that is what dependency inversion mean and helps to achieve. So um I know I haven't fully grasped this yet, and I believe that the more projects I work on, then I would grasp it fully. But I understand the primary um the the how should I put this? I think I understand the primary principle of what the solid design principle mean and what it helps to achieve. But the more projects I build, and as we get along with this, we'll come to a robust understanding of this. But the basics is understand the principle, and going forward it becomes clearer and more easier. So, and I believe I understand the basic principle of it, and we are going to apply this together on this students management class. So now looking at our code, this is our class here. And from this class, we can see that, okay, here, this only has a single responsibility. So we've achieved the S factor here, which is single responsibility principle. And for some, you might be used to this method. It's still the same thing. So this might be what you're think maybe from C sharp 13 upward. Okay, now if this take for this might be what you're used to before, but it's should do the code so I can put on this. Getting skills. Okay. So why is it giving me an error? Right? Okay, so an error for this. I'm getting an error here, but this shouldn't give me an error. It shouldn't give me an error because this code is correct, but okay. I wouldn't want to waste much time on this. I just want to let you know that there's another way for using the constructor. But let's just get along with this. Come to this later. Um, okay. So here, our class has achieved the single responsibility principle. So what we do now is let's go to the manager. As we can see here, we see that this place is so compact. There's no segregation of concern. no interface segregation here because the add students, the remove students, search students, these three no method has to do with the filing system, like the storage system. It has everything to do with the storage system, but as you can see now, we also have highest score and lowest score because there's need for us to always separate business logic or business rules from every other every other thing. And these ones are just business um, logics and or business rules, if I may put it that way. So now we are going to be segregating our concerns, and here's what we will do to achieve that. So here, let's get along with this. This single student management manager, it exposes everything, and we need to break this down. We need to create small and focused what's it called, interfaces from here. And so what we'll do is we'll create a repository, but let's and that repository like a repo to help to handle the data storage and the data storage and fetching data, storing data. So that's what the repo simply does. And but don't forget, we also need to do loose coupling so that they don't directly depend on each other. Let's bear that in mind. So we are adding an interface, I repo or uh, I student repo, students repository, okay, repository, is my correct, correct. Okay, so here, don't forget I said an interface is like a contract. So what are the things that we want to do? Let's come back to the student manager. These are the things we want to do. Things that affect the storage. So which is add student, remove student, search student. So let's see. This is a bool, remove is bool, students, void, bool, and students. So here, void card. So we're saying students. Then we are saying, should we use void remove or bool remove? Okay, let's use bool at the moment. We'll see which one is best to do as we get along, depending on what you want your code to, functionality of your application. So in the, oh, sorry, what's wrong with removed. Then the last one is students set of null type. Is it find students? search students. Okay, let's just find students. What's this search parameter? Okay, student's name. So we'll say find by name. So it says string name. So we're finding the student by name. Should we add one other thing? Okay, let's say we want to just um fetch all the students. Okay, so let's say, and this should be read-only. So we can say I read-only collection of students. So this I read-only tool, once you see how, don't forget I said it's an interface. So we are also, um, we are also using the inbuilt interface functionality of this I read only. So say get all. We are getting all of the students. So yeah. So now we are trying to segregate concerns and have loose coupling. So now that we have this, we can now create a class that implements this. And I will tell you the reason why we are doing this, because for instance, we might want to do an inbuilt filing system. Let's say we want to save to a list. We can have a class that implements this student repository by saving data to a list. Let's say tomorrow we also want to have another that saves to a database. We can also create a class that implements this but uses a database, so that we won't be directly dependent on a single way of doing it, of saving data. Just like I use the supermarket, the payment options in a supermarket, that we have the card payments, cash payments. So we are not tied to just one pattern of doing it. We can substitute the list method for the DB method. We can substitute the DB method for the list method. So that's also what we are trying to achieve here. And now let's create another class to implement this. So we say student repository. So and this inherits this. So let's implement this. So to implement this now, we can say, uh, let's come back to our code. If we want to make it faster, we can just, you know, just write it offhand again. But okay, let's write it offhand, because writing codes helps us to understand and get used to it better. So here we come here because we are using lists. So we just say we declare private read only. No, we are not doing adding lists of students. Don't forget we are trying to private read only list of students. So sometimes when you use private and you can I think naming convention or style of .NET, you can use this underscore here. That shows, it's just a way of telling us that this is private and it is read only, kind of. So that's why I'm using this here. So this, then you can also use new like this. It's also acceptable, but I prefer using this style. Yeah. So with that done, we can now start implementing the contracts here. And now we start by the contracts at students. So we say if our student is null, that means if the parameter or the arguments, if it is null, so don't forget we must also try to make our code readable and uh, this is going to be like an argument null exception. Yeah. So what do? We say name of students. So that is if it is null. Then here say student dot add uh, then we have the students. And that's for the, let's see what's the same. Okay. Okay. You can see it's telling us that instead of using all this line of code, we can achieve that by simply using just this one statement here, argument null exception or true if null. So all this is wrapped into just a simple line of code. But we are still learning. So let's understand the principle. Let's understand the intricacies of it, and then we can now metamorphose or graduate into using this. But for the sake of our learning and our progress, let's stick to this for now. So now we have to implement find by name, but I would like to do this first. Okay, yeah, we can implement the find by name string. So to do this, we also have to test if the name entered, if it is not null, and if uh okay, let's let's just do let's just do so what are we returning? We are returning students. So we are saying return students, return students. Yeah. Dot, that is by using this method first or default, first or default, saying x dot name is equal to name, and that's it. So that's a find name. Then we're also doing to get all. So to get all, we know we are returning all the students. And don't forget, we are using read-only collection. So we are returning this as just a read-only. So we are saying return students dot plus. So we are returning the lists, the entire lists, but as read-only. Then remove students. So to remove students, we know we are just doing students. Oh, sorry. Let's remove students. So that is all we are doing for remove students. Oh, okay, we set this to be bool. Should we set this to the bool or void? Okay, let's make this void. So let's make this void. So yeah, we have implemented the I student repository now. Now we've implemented this. So let's look at, let me think, what else are we going to do? Mm, Okay, okay, okay. So now with looking at this students manager, we've segregated this from those parts down here. We've lifted it and we've segregated it. And if we've even achieved the loose coupling by defining the I student repository and the implementation class student repository. So let's just remove this. So that has been achieved. So what else can we achieve? So let's also look at now creating a service interface. And don't forget, all we are still doing is interface segregation principle. So let's create another class. And here we are doing high student service. So this is also an interface, and all we are just defining here is the the contracts. So we are saying void add students, students. We are saying void remove students. We are saying is it void? No, void add student, void remove students. What else? What else? What else? What else? We are bringing all this as a student. Oh, student manager. Okay. Now we are bringing all this into this student service. So we are saying double calculator, which means highest score, double calculates, or should I say double average score. I think that's better. Double average score should be, then we have highest score. Highest. Then we have int lowest score. Then we have the count passes. And the int count passes. Then here we have void. Is it find? Yeah, void by name. So we have void find by name. Mm, what else, what else, what else? Let's do it like that. So now, um, that's that name. Okay. Then we save it. All these are just contracts. So now because what we are trying to do is, I'm trying to make sure that they are not directly dependent on, just like, okay, let me return the stuff I removed from here. So now what we are trying to do is creating an interface and ensuring that there is loose coupling. So this one is controlled by another class, and here, as you can see in the I service, you see it is not directly dependent on just the way it was executed here, because here it was just directly dependent on this. So this student management class or manager class implemented all this, but we want to make sure that all these things are separated. So, and that is why we've created the iStudent service. So let's implement this. Oh, this video is getting too long already. Let me speed up so that we can bring this to a close. So now we have to create a we created iStudent service. Now we're doing student service, which we implement the iStudent service class or interface rather. So so now we are implementing this. And to implement this, this is where the version dependency inversion comes in. So what are we inverting? What dependency do we need? We need the student repository, and what else do we need? Yes, that is the major, because why do we need the student dependency, the student repository as a dependency? Here we see in the high student service, all these functions, they have student, find by name, remove students, uh, let me say find students by name, remove students. All these are functionalities defined in the iStudent repository to add, to remove students, to find by name. So, and we need the student repository, which is the proper implementation of iRepository for that. So, what we are doing is we are saying we want to invert this iStudent repository. And note, we are not using student repository directly, but we are using iStudent repository, which means that, just like I said earlier, that for this student repository, here we are using lists. What if we decide that we want to also create, let's say, a DB student repository that implements this iStudent repository? So we'll be using DB instead of lists. Do you understand? So, which means that this is where the list curve substitution stuff and principle come in. So, which means that we can either say, okay, we want to use this student repository, or we want to use the DB student repository, which are both implementation of the iStudent repository interface. So we can substitute any of these, and that's why we are making reference to this iStudent repository rather than the student repository that is making use of a list. So which means that tomorrow we can we can make use of a DB student repository, and our code is still going to run smoothly without any error. And then we can also test our code easily without any expensive cost. Also, it will not be expensive to test our code. I hope that is understood. So let's get along here. So here we are saying, don't forget private read only. So we are saying I student repository, and I'll use repository here. And here we say student service. So it should be public. I should put access. What is a public student service? Then in here we say hi student repository. Hi student repository. Then this is equals to this. So now it now depends on the repository we pass in. If we pass in this student repository, it knows we are working with this list. If the repository we are passing in is a DB student repository, it works with that. So you now see where that comes in. So you can see this is not tight coupling. It's not directly dependent on anything. So we can easily switch and substitute without our code crashing. It still recognizes it and works well. So that is what we are trying to achieve. I believe we are understanding this gradually. I know it's a gradual process, but it will definitely sink in. So here, what are we doing? We are saying uh, we can say this dot repository. It does not really matter this, but okay, let's see what this is saying. Use primary constructors. Okay. It's saying we can also use primary constructor. Let's see how to use the primary constructor. Okay, I understand. We can use the private, but let's. So if we want to use the private constructor, that means we'll just comment out all this. We can also decide to work with that and say I repository. That's just the same thing we are doing. So we just say this is equals to repository. That's all. So I will comment all this out. That's just what is saying. But let's leave it as it is. Or should we stick to this thing? It's the same thing, but let's go back to what we were using earlier. So let's go back to this. So now we are just saying repository, uh, repository dot add students. So assume that this repository is a DB student repository. So is it just going to add students? So here we are ensuring that this it doesn't bother whether the type of storage we are using, maybe it's DB, it does not matter. That does not matter to this. What it does is simply ensuring that the student or the data is added. So maybe the database or the list or whatever So that's just what we are trying to achieve. So I've done. No, I don't like this thing being scattered like this. So let's do find by name. So I'm going to move this up here. So so we are finding by name. We need to be proactive in our thinking because we know that it is possible that let's see, it is possible that this name here might either be empty or it might not be correct. So how do we undo this if the user is entering uh a name that is empty? If we look at our student manager and we come down to search students, we'll see that this is taken care of because first we test if the student is null or white space. Then if it is, we say return null. So it's not going to return anything because obviously it doesn't exist. But if that's not the case, then we return the student. But sometimes uh, a user can also enter, let's say, we want to ensure that this works regardless of the case, maybe lowercase or uppercase that the user has entered. So to do that, let's come here. Let's go back. I just want us to understand the edge cases that we have to, consider. So we are saying if string dot is null or white space, we can use null or empty or whatever we want to use. That's sorry, that's correct. So we are saying, should it throw an argument or should it just return null or say it does not exist? Now, it depends on what we want to do, right? Oh, okay. Let's say return true null exception. Okay, let's leave it at true because I'm just looking at what will work better. So now we are saying, is it void find name? If it is find by name, then it shouldn't be void. It shouldn't be void. It should be students. It should return students, not void. So we are returning students. Oh, sorry. Those are some of the things we need to be mindful of. So we are returning no repository. Then find well, let's come here. I think we still need something. Okay, student repository, student manager. This is our student manager. This is our student repository. So we need to change one other thing. Name dot equals name dot equals name, and there is this uh, uh, I've not gotten to master this, but string comparison, string comparison, and let's ignore, I mean, ordinal ignore case, yes, that's the right word, and close the bracket, yes. So that's that for that. What else? So now we go to remove student. So I'm also bringing this up right here. Yep. So remove students. We also have to consider that the student that is being removed here. Are we removing student by student, or should we remove student by, how did we implement that here? Let me see. Remove students. Okay, we use student name, not student, but should we remove by student name or remove by index? Okay, let's remove by student name. So that means we have to come here, I student repo, remove by student name. No, by student. But we need to first find, yeah. Okay, now I understand. So it is very, very easy to, to to mix things if care is not taken. So what we want to do is we are removing a student, but we need to first find that student by name. So once we get the student by name, then we remove the student. That is what we want to do. So, but the first things first, we need to also see if uh, the student does not contain white space or something. So let's look at that here. There's the student repo. This is the student repo. Where's the remove student? Okay. So now we're going to the student service. And this is find by name, right? Here we have this. When I'm repeating, I want to ensure I am not repeating. Uh, okay. So here we just do the student is equals to find by name. Yeah. So I'm saying if student is equals to null, then true is no argument null. This argument. Let's see, I want to say it does not exist. Key not found exception. That's the word. Key not found exception. So, but if that's not the case, we say repository dot remove student. So now we move down to uh, average score. So let's go here because we need to work with what we have so that we don't make any mistake. So we say we are trying to use okay, there's ensure that list is not empty. So let's look at what this is all about. Okay, if this is this, that is that, this is that, and that is that. So if the list is 0, then student list is empty. Oh, okay. So let's do that here. Okay, I'm sure. Guys, please don't get bored. I know this is getting long, but we'll soon there. I'm sure not MC. I'm trying to look for a better name to give to it.
On approach.
That was a mistake. So we're about tidying up with our code. So here, to calculate average, we need to show um the list is not empty, and to do that, we just check if list is empty. So if it is, we get that, or if it is not, we are returning. Uh, let's go back to this. I want to be sure we are not making any mistake, please. Okay, okay. So we are returning. Getting home. That's do we have get oh the repository is not correct. Sorry. Get on okay. Get on then from get on then dot average is even can see it has been highlighted already. Then x as x that's called after the capsule. So this is what we are returning, right? So then for uh, count passes, count passes, we are returning uh, return repository.getAll.count. Then here it has to be x into x dot as passed. Then for the highest score, here we really don't need to ensure it's not empty because if it is empty, it's just going to bring return 0. And another thing, I'm trying to see, trying to see get all dot count. Can be less than 0, can only be equals to 0. Which one do you think is better? Should we use it this way? Or should we use if repository is equals to null? Which one do you think is better? You can drop your answer in the comment section below. Or do you think using both like repository equals to null and repository.getAll.counts is equals to 0? Do you think combining both or using um each of the two, which one do you think is best approach to be used? Please, you can comment down that in the comment section below, and let's learn from each other. Thank you. I think we're almost done here. So here I said you don't need to check if it is empty. If it's empty, it's just going to return 0. That's it. So for IS core, we need to check if it is empty. So check if list is empty. Then here we say return repository. Don't know why my spelling is get on first, then dot max, then say x into x dot score. So it's to be conscious of uh, the code to ensure that we don't have any error. So yeah, I'm just going to copy this, save time. The time is long gone, and change this to mean. So we are still getting show put does not implement interface find student by name. Okay. Find students. It should be find students by name, not find by name. So that's where we are getting the error from. I think there's another one. Find, okay, find student by name. Yeah, and that's it. So we've achieved separation of concerns as interface segregation. We've also achieved dependency inversion here by doing this, and we've also achieved least cost substitution method. We've also achieved open and close because here our, for instance, this as it's iStudent repository, if we have any other behavior, we can simply add it to it, but this has captured everything. And from we've also achieved single responsibility principle, which is this single responsibility. So we can do away with this student manager because it exposes everything. This is just tight coupling. So we can from here just delete student manager. Thank you for joining us. We need to delete you now. You have no use to us anymore. So yes, we have that. We have that. So here is just helper method to get the student name, to get student score, and to print items in the list. So as you can see here, I think we still need to work on this print item in the list because let's see, print item in the list. Yeah, this is the argument we pass to a list of students. So it should be the repository. So it's working on the repository now, not the the students any longer. So we can even add the print into the student service here because it's also a service. So print the list of all the students. We can add that here and remove that from the uh, helper uh, yeah, from the helper class here. So yeah, we can also do that. Okay, let's do that and see how we can achieve that. And if we want to, we can also put that in a separate interface because we might want to print as PDF and I want to print to paper. Uh, yeah, those are the things. So and to do that, okay, let's use an interface. But mind you, don't forget, solid principle is advised to be used when we are working on a big project. But we can start practicing it, with the project we build from now so that we can fully understand and grasp the power of solid and understand it better. So, but don't forget, it's beneficial to use it for a big project that you know we know that can span long-term goal even into the future. Projects we know that the future could also affect it in a way that there are new things that could be added to the project for just to ensure scalability. That's all. So if it is a small project that does not really need to be expanded or to be scaled, then there's no need using um, solid design principle. I hope you understand my point. Uh, I think this print info. Okay, let's use print info. For instance, just an example, because I don't know what name to give to it, struggling with the name print info. So let's say, what do we want to print? So let's look at the students. Okay, we've deleted the have we? The helper inputs. Okay, prints. So it's void. So we are saying void print. So what are we passing in as arguments? Are we passing in anything as arguments? Let's look at this. So this is saying list of students. This is saying student list. Hmm. Now let's look at this. Something I'm thinking. Yeah. So here is saying lists of students. Okay, student lists. It takes in student list as the argument. But do we need that here? Okay, no, I don't think so. Let's go to the implementation class. So here we say print students. So we're saying this implements I print info. So, and we are saying uh, public void print. So here, but we need to do something. We need to do something. We need to do. What are we passing in here? Or should we just use this? Oh, okay. Let's go back here. I print info. Let's say I uh, repo. I students repo repository. Okay, I think this is good. Down here, we can say the same thing. Repository, right? And here we can say This is 1 hour 40 minutes. Uh, Guys, I will bring this to a close now. Don't forget we are learning together. I'm going to work on this and I'll share the complete code with you in the next class. Thank you for joining. Thank you for your time as we learn together and go on this journey together. My name is Jacob and this is .NET-Dev-Journey with Jacob. See you all in the next video. And please don't forget to like and follow or subscribe to this channel so that you can keep getting updated videos as I upload them. And please comment, drop your comments in the comment section. Let me know what you think. Let me know your recommendation, your contribution, your questions, as this will help me um become a better developer. Thank you. See you all in the next video.